Okay, so for our last lesson this week, we're going to look at segments. And I better tell you what a segment is. It's not overly bad, to be fair. It's just one new thing I've got to show you. So if you tab this down your notes, this is a radius and this is a radius, okay? And you all know that the area of a sector is the angle out of 360 times pi r squared, okay? Now, I'm going to give you a new formula for something different. See if I'm drawing a straight line here? I'm trying to. See this here bit? That is called a segment. So it's like the bit you chop off. And if you sort of look at that, it looks like what a Terry's chocolate orange would look like. Okay, so that sort of helps me remember to think of it as Terry's chocolate orange. Now, what we're just going to work out, how do you work out this area of a segment? Okay. Now, if you have a wee look at that, I'm sure you can sort of see the segment area of that. So area of a segment is going to be the area of the sector. Take away the area of the circle. Okay. Now, so how do you work this out? Well, I'm going to give you a new formula for an area of area of a triangle, that should be, sorry. I'm going to give you a new formula. You know the area of a sector fine. Area of a triangle. I am going to tell you is a half times the radius squared times sine the angle. Sort of a strange one. But that's the one we're going to be using. Okay, so the area of a segment, now I would never remember it like this. I always remember it as a sector, take away the triangle. But let's put it together. Area of the sector is the angle out of 360 times pi r squared. Take away the triangle, which is a half r squared times sine a. So that's quite a tricky wee one in there for you to remember, okay? I am going to do two examples with you. So example 1. So we have a circle like so. And here's the centre, it's going indicated by a wee O. And draw this line across here. And if this is 8 and if this is 130, and I want this bit here. Okay. So area of the sector, remember that's a whole slice. It's the angle out of 360 times pi times r squared. So I'm going to work that out first. So 130 divided by 360 times pi times 8 squared, giving you an answer of 72.6 centimetres squared. Now remember the new way of triangle. So the area of a triangle is a half times r squared times sine your angle. So it's a half 8 squared times sine 130. So how do you do that? 0.5 times 8 squared times sine 130. Just put it in as you would say it. So 24.5. So then area of the segment is the area of a sector, take away the triangle. So it's 72.6 minus 24.5, giving you an answer of 48.1 centimetres squared. I think it'd be good to do another one, and then I'm going to tell you what I want you to do for handing in homework. So let's draw another wee sector. That's the centre. That's 3.2. Here's the straight line, and I want this bit here. And let's say this angle is 75 degrees. Okay, so area of sector is 75 out of 360 times pi r squared, because it's area. 75 over 360 times pi times 3.2 squared. Okay, and if you work that out, 75 divided by 360 times pi times 3.2 squared, it gives you an answer of 6.7 centimeters squared. Now, do you remember how to do a triangle? So area of triangle is a half the radius squared times sine the angle. Strange, isn't it? So it's a half 3.2 squared times sine 75. So we'll just take you through that again. Half is 0.5 times 3.2 squared times sine 75, giving you an answer of 4.95. So the area of segment is the sector, take away the triangle. So it's 6.7 minus 4.95, giving you an answer of 1.75 centimeters squared. Now, what I want you to do is I want you to do exercise C, questions 6 and 7 as a handing in homework. So I'm just going to talk you through it. I can get this up so you can see it. There is question 6. Okay, so what I will be looking for in question 6, I'll be looking for area of the sector. Remember that one? So it would be the angle out of 360 times pi r squared. So I'd like you to put your numbers in and work that out. Then do the area of the triangle, which is a half r squared times sine the angle. So it'll be half times the radius is 9 squared times sine the angle, working that out. And then I'd like to see area of segment. So it's going to be the sector, take away the triangle. Let's see what you get for that. And then I would like to do question 7, exactly the same way. So area of the sector, that's the slice. So it's 74 out of 360 times pi r squared. So put your r in there, work it out. And then I'd like to see area of your triangle, which is a half r squared sine, thinking of A level there, half r squared sine A. So it's a half times your r squared times sine that angle. Just put that in your calculators. And then area of segment is when you subtract the two. So it's sector, take away triangle. Now, and give you the answer. I would like your page laid out exactly the same as mine, please.